Today I want to discuss something related to two compound statements, that is conjunction and disjunction. So in the previous lecture you have seen that the compound statements have truth values the way simple statements have, and the truth value of a compound statement is either true or false, as it is the case with a simple statement. Now, you know that a compound statement involves several simple statements, and every simple statement has a truth value. It is either true or false, and therefore the truth value of a compound statement is dependent on the truth values of the participating simple statements and also the relationship which they have among themselves. So we have seen that the truth value of a conjunction is decided in one way and the truth value of a disjunction is decided in another way. Conjunction is true only when all the conjuncts are true, and the disjunction is false only when all the disjuncts are false. So I wish to further elaborate on these two kinds of compound statements for the reason that you will require the formulation of conjunction as well as disjunction in your writing. So the advantage of learning logic is to improve on the logical coherence of whatever we write. That is the advantage of learning the principles of logic. So when we talk of decision of the truth values, in fact, the objective is to make you aware that how a sentence, how a statement is read, how a statement is understood, how its meaning is understood. And it is rather easy to get into the meaning of a statement when it is simple, but it requires little effort when we have a compound statement to understand the meaning of the statement. And the effort is directly proportional to the complexity of the compound statements. So by learning the logical principles to decide the truth value of a compound statement, you learn how to make sense of them and how to decide whether they are reliable or not. So I wish to explain a bit more regarding the nature of conjunction as well as disjunction, so that it doesn't remain simply a mechanical exercise for you to learn how to decide the truth value, but also you become aware that how these things are to be utilized in our ordinary writing. So what I think I should first tell or remind you how the truth table is constructed for a conjunction and disjunction. So for the sake of simplicity, I will consider only the simplest form of conjunction as well as disjunction. Look at this table. I have drawn this table with 5 rows and 3 columns. So you have 3 columns and 5 rows. In the top row, I have written 2 simple statements, P and Q, and the third column is the relationship of conjunction between them, P dot Q. So as you are already informed that depending on the number of component statements, we decide how many possibilities of truth value of their combination could be. So there are 2 statements. So we begin 2 to power n. N is the number of simple statements. So 2 to power 2. We have two simple statements. Therefore 2 to power 2, that equals to 4. And whatever comes, so 4 is divided by 2. That means 2. So we write 2t below p in the first column and 2f again below in the first column. So this way we draw the table. So the first column has 2t and 2f. Then half of this will be here, 1t, 1f, 1t, 1f. And you have also learned the rule how to calculate the value of a conjunction. So P dot Q is true only in one condition, where P and Q both are true. So in the first row, P dot Q is true because P is true and Q is also true. Then in the second row, P is true, Q is false. So that does not satisfy that condition, therefore it is false. Similarly, in the third row, P is false, Q is true. Again it is against the condition, so this is false. And last one is obviously false because P and Q both are false. Now, what I want to suggest further here, if you insert one more column to the right and change the place of P and Q. So instead of writing P dot Q, let us say we write Q. It should be small in fact, so that it remains a formula. We write formula in variables. So suppose we reverse the order. We write first Q and then P. So what would be the value of Q dot P? So in the first row you see Q is true and P is also true. So it satisfies the rule of conjunction. So it is true in the first row. In the second row, if you look at Q, that is false and P is true, so this is against the rule, so that becomes false. So Q dot P is false in second row, where Q is false and P is true. Similarly, in the third row, Q is true but P is false, so their total conjunctive value will be false. And the last row, since both are false, so it will be false again. Now compare the truth value of P dot Q and the truth value of Q dot P. What do you notice? You notice that P dot Q is true in the same row, Q dot P is also true. Similarly, where P dot Q is false in all the remaining three rows, Q dot P is also false. What this means? P dot Q and Q dot P have the same truth value, and therefore logic suggests that they must have the same logical relevance. For some, Q dot P and P dot Q mean the same, but that is not the case. In fact, it is not always the case that P dot Q and Q dot P mean the same. Take an example. Suppose I say you mix rice and pulses. So you have a conjunction of rice and pulse and you take lunch. So one would say that you have mixed rice with pulse. So P is rice and Q is pulse. So if you say you have mixed rice with pulse, don't you think that it means the same when you say you mix pulse with rice? In fact, the total outcome is the same, right? Whether you are putting rice first or pulse first in your plate, it hardly matters because both are going to be mixed, right? So in that sense, P dot Q means the same as Q dot P, but it is not always the case. Suppose you say that X is dead and he is buried. Take any actual person's name. Ramesh is dead and he is buried. So Ramesh is dead, let us say P. Ramesh is buried, let us say Q. So Ramesh is dead and he is buried is P dot Q. And if we just reverse the order, that Ramesh is buried and he is dead, it becomes Q dot P. But look at the meaning. The meaning of Ramesh is dead and he is buried is one, and the meaning of the other statement, that is Ramesh is buried and he is dead, entirely different. So it is not always the case that P dot Q means the same as Q dot P, but in this or two-valued logic, we consider them equivalent. So when you write actually the statement, you have to take care of this fact because a context will tell you whether you can write P dot Q in the same sense Q dot P, or the context demands that their place should not be changed. So if you start with writing P dot Q and in between your write-up, if you are changing the order, you must have a proper justification for that. Logic will simply tell you that the reversing order will not have any effect on their truth value. But then the ordinary language is something different, right? So consider the context is important when you are to suggest that P dot Q means the same as Q dot P. This is the kind of sensitivity you need to show when you write a conjunction, and you must be aware that the truth value of a conjunction will always be calculated as per the logical rules, but meaning may be different. So the context is important so far as the reading of meaning is concerned. And this is symbolic logic, and the main concern of symbolic logic is not the meaning, but the structure of the statement, the organization of the components in the statement and their relationship. Now, one interesting thing about the conjunction is this. Remember when you learned simple statement and you learned the negation of a simple statement, there you noticed that the value of a simple statement is simply reversed when it is negated. You have a conjunction, and this part is more important. You need to pay more attention on this part. Once you have a conjunctive statement and you want to deny that conjunction, that means you want to negate the conjunction. So what you need to do, the principle of simplicity, the principle of economy demands that you should do the minimum so that you can easily negate a conjunction. So you don't need to go by negating or putting a lot more effort. So I wish to just show you that how do we understand the negation of a conjunction. So what this means, that we are going to deny that P dot Q. So we put negation outside and then small letter P and Q. So negation of P dot Q. So you need to just see what is the value of P dot Q, and then you need to just deny that. So immediately you see here, this is the value of P dot Q. So if you put negation before T, it becomes false, right? So in that way, you see in first row it is false, and in the remaining row it is true. Now I was suggesting that we need to have minimum effort to deny the conjunction. So here I wish to refer to the rule which is taken for calculating the value of conjunction P dot Q, and the rule says that P dot Q is true only when P and Q both are true. Imagine a situation that we are going to deny that P dot Q is true, right? The way we have done here. So we are going to deny that P dot Q is true. So suppose P dot Q is true and we want to deny that. Do we need to deny that P is false or Q is false? What we need to do? The suggestion is that, and the suggestion is drawn from the 3 lines here. Look at the condition where P dot Q is false. And what is common between these 3 rows? Look at the commonality. The common thing you must notice that in all the situations where P dot Q is false, at least one disconjunct is false. At least one. In the second row, Q is false. In the third row, P is false. And in the last row, both are false. That is fine. But when I say at least one is false, which means that if any of the conjuncts out of n number of conjuncts is false, then the total value of conjunction is false. Now, we are learning rule how to deny a conjunction. We want to deny that P dot Q is true. So what we need to do? We need to simply say that either of the conjuncts is false. Now there are 2 conjuncts. So which one is false? Which one you need to deny? The suggestion is that you can deny any of them. But how to represent in symbols this denial? So the suggestion is that if you want to deny that P dot Q is true, you can say that either of them is false. So how to say that in symbols? You need to just say that either P is denied or Q is denied. To understand the value of negation P wedge negation Q, you need to refer to the principle of disjunction. And there you have learned that a disjunction is either true or false. Now, under what condition a disjunction is false? It is false only in one condition, and that condition is that all the disjuncts are false. So what are disjuncts here? One disjunct is negation of P and the other disjunct is negation of Q. So you need to see that negation of P is false and negation of Q is also false in order to say that negation of P wedge negation Q is false. But that is not exactly the point. We are trying to understand the negation of a conjunction. And for that matter, we have decided that we don't need to deny both, because the row 2nd, 3rd and 4th suggest that if you deny just one, that will do the job. But Which one are you going to deny? The denial cannot be an arbitrary kind of denial when we are making rule. So we consider all the possibilities. The way we have decided the values, all the possible truth values of P dot. Similarly, we have to decide all the possible truth values of its denial. So for that purpose, we said that either P is denied or Q is denied. Now, to understand that this is the denial of P dot Q, we need to see what could be the value of negation P. So let me introduce one column just at the right side of P and also Q, so that we can see what is the value of negation of P. So this is the denial of P and this is the denial of Q. Now let us draw the value of the negation of P from the first column. So negation of P in the first row would be false. Negation of P in the second row would be false, and in the remaining row it is true. Now calculate the value of negation of Q. So in the first row it is going to be false, in the second it is going to be true, in the third it is going to be false, in the last it is going to be true. Now let us try to put negation P and negation Q in the relationship of disjunction. So look at the first row. Negation P and negation Q, both are false. So what would be the value of negation P with negation Q? When negation P and negation Q are false, the disjunction between them will be definitely false, right? Now look at the second row where negation P is false and negation Q is true. So what would be the disjunction? Certainly it is going to be true, because a disjunction is true in a condition where just one disjunct is true. So here you find negation Q as true. Now look at the third. Negation P is true and negation Q is false. Again, this is going to be true. So true with false is true. And the last row, true disjunction, true is true. Now the value of negation, the denial of P dot Q, and let me make it a little colorful. The value of the negation of P dot Q and compare it with the value of negation P with negation Q. So look at these last two columns where negation of P dot Q is false, negation P with negation Q is also false, and where it is true, this is also true. So in the all remaining situations, they are true. What you draw from this? You have to say then that negation or denial of a conjunction is equivalent to the denial of one conjunct or the denial of the other conjunct. Whatever we have seen earlier, that if you want to deny that P dot Q, you don't need to deny both of them together. You can just deny one, and that will be the denial of the whole of conjunction. When you deny P dot Q, you notice that the truth value of this is exactly the same as the truth value of negation P with negation Q. So negation of P dot Q, is equivalent to the negation of P with negation of Q. And remember, so if you want to deny something which is like P dot Q, you can say either P is not true or Q is not true. And this you need to keep in mind when you are to write the sentences. So suppose someone has said something in a conjunctive form and you want to refute the position of that person. You don't need to examine each of the conjunctions given by the person. If you can just demonstrate that one of the conjuncts is not correct, you have demolished the claim made by that person. And this is the advantage you learn in logic. Similarly, we will learn in the next lecture what it means to deny a disjunction.